Hello everyone and welcome back to another problem of the day, and today's problem is titled Adventure in a Maze. In this problem you are given a matrix or a maze of n cross n, which is nothing but an n cross n grid, and every cell in that maze contains the numbers 1, 2 or 3, and they have given the condition that if that cell contains 1, then you can traverse along that maze only in the right direction, and if that cell contains 2, then you can traverse only in the downward direction, and if it contains 3, then you can go either right or down. And given this maze or given this matrix, what your job is to find the number of paths to traverse from the top left corner to the bottom right corner. And also while doing so, we also have to calculate the maximum possible sum uh, to try to travel from the top left to the bottom right. So for example, in this case, for the given matrix or the maze, you have total number of paths to be 4, and out of the total paths, the for the 4 paths, the sum is, that is nothing but the sum of the values of the cell is 18, 17, 17 and 16, and of those the maximum value is 18. So we are returning the answer to be 4 and 18, where 4 is the number of path and 18 is the maximum sum from those paths. So how are we going to solve this problem? First of all, we are going to use dynamic programming because removing path would be a sub problem and it would be repetitive. So dynamic programming is the right approach to go about this problem. So let's get on with the problem itself. I have written the example over here on the whiteboard. So what are we going to do? So to begin with, what I'll do is I'll create a another 2 by 2 matrix. Let us call it DP of size n cross n. And using this, I'll be storing the paths, and for every cell I'll be computing uh, the number of paths to reach that particular cell. So let us first fill in the dummy values, which is nothing but 0 in our case. So for the 5 columns for the first row, it would be 0, 0, 0, 0. Similarly, 0, 0, right? For the last row, again 0, 0, 0, 0 and 0. Now our task is to traverse from this point up till this point. So first off, I'll mark this point to contain the value 1, meaning since it is a starting point, it has to be the value 1, because there's only one way you can reach this particular point. Now I'll be traversing the matrix normally. So coming to the next point, next cell value, which is at position 0 comma 1, we have 0 comma 1 to be 1, and the previous value, since it is the first row, there is no possible way to travel from the upward direction, and that is travel downwards from upwards. There's no possible way, right? So we have to consider the right way, that is the way to travel from the left direction, that is coming from here to here. And while doing so, we'll check the value of that particular cell. So what is the value here? It's 1 over here. And what does 1 tell us? 1 tells us that we can only travel in the right direction. Since we can only travel in the right direction, what I can do is I can simply take in the value of this computed cell, that is 1, and I'll place it over here. Alright, that is done. Now again, I'll move on to the next cell, consult the previous cell. Since there is no cell that we can travel from the upward direction, I'll only consult the cell in the left direction. So I'll consult the cell 1 here, and since it is 1, it means that I can travel in the right direction. So I'll consult the value computed for that particular cell, that is the cell at 0, 1. For 0, 1, its value is 1. So I'll simply replace this 1 from 1. This simply tells us that there's one possible way to reach this cell, and to reach this particular cell, there's one possible way. So we are calculating the number of paths to reach the current cell that we are considering. So we are done for 3 now. Now moving on to 2. Now again for 2, we'll be checking the left cell, which is nothing but 3 here. And since it is 3, it means that we can travel either right or down direction. This simply tells us that we can move to the left, and since that is the case, we'll change the value from 2 to be 3. Now coming to the next cell, which is 1 here, I'll again consult the previous cell value, which is 2. Now 2 tells us that we can only move in the downward direction. So there's no rightward movement, meaning there's no possible way to reach this particular cell. So we'll be leaving the 0 as it is. Now coming to the next row, and the next row value is 0 here. That is the number of path is 0. Now there's no possible way to reach this from the left direction. This is because it is the starting column of the matrix. That's why we'll be consulting the upper row only. Now considering the upper cell value, it is 1 here, but the value of that particular cell is 1, which tells us that we cannot move in the downward direction but only rightward. Since that is the case, we'll be storing 0 as it is. Similarly for 2, the upper cell value is 1. We'll be storing 0 as it is. Also, we'll be consulting the leftward cell. This is because there is a possible way of reaching this particular cell from the left direction, that is from cell 0, 2, 1. Well, not 2, 1, 1, 0. And we'll be consulting both these cells, and since there's no possible way to reach up from up to here because the value of this cell is 1, and also for this cell we can traverse from here 3 to 2, but the value for 3 is 0, so we'll be storing 0 as it is. Now consulting this cell 2 over here, for 2 the upper cell value is 3 and the cell value to the left is 2. So from both the directions we can reach 2, so we'll be consulting the values there. For the upward cell 3, its value is 1, and for the cell to the left, its value is 0. So we'll be simply replacing this value with the sum of the paths from the upward and the left direction, that is 1 plus 0, which is nothing but 1. Now checking for this particular cell, we have 2 above and 2 to the left. Since it is 2, we cannot move in the right direction, that is we cannot move in the right direction but only from the upward to downward direction. So the value for this particular cell will only include value of this cell, which is nothing but 1. All right. Now coming to this particular cell 2, again since it's 1, we cannot move to the downward direction, but to the left of that cell we have the value 1, so we can move in the rightward direction, and since that is the case, I'll replace this value to be 1. Similarly for 1 over here, we have 3 above and the value for 3 here is 0, so we'll have 0 in this case. Now coming to the next cell, we have the value 3. The above value is 2, meaning we can move downwards, and the left cell value is 1, meaning we can move to the right. But both these cell values are 0, so we'll be having 0 as it is. Now coming to the next cell again, we have 3. The above value is 2, and the left cell value is 3, meaning we can traverse in both the direction. We'll take in both the values, that is 1 and 0, and we'll store the addition of these, that is 1, meaning we have one possible way of reaching here from this direction or this direction. Now we'll check in for the next value, which is 1. Again, we cannot move from downward direction from this one since it's 1, but we can move to the right direction from this cell because its value is 3. So we'll take in that value, that is 1 over here, and we'll store 1 as it is. Now coming to the last cell, which is 3. Now for 3 here, we can move downwards also, and also we can move towards the right, meaning we have 2 possible ways, and the value of those cells is 1 and 1, which is nothing but 2. That is addition of these 2 paths, that is 2. So this tells us that there is 2 possible ways of reaching this particular cell, and we are computing those values by consulting the left cell value and the upward cell value. Now erasing this, I'll have 1. We cannot move upward from 1 over here, so we'll have 0 as it is. For this particular cell, we have 2. We can move downward from 3 and rightward from 1. So our value would be addition of these two, that is 0 and 0, which is nothing but 0 itself. Now for this cell, which is 3, we can move downward and right. Well, we can move downward but not rightward. So we'll be taking in this value only. So it will be 1. Now consulting this one, checking in for this one. We cannot move downward, but we can move rightward from 3. So we'll be taking in only this value. So the value will be 1 here. Now for the last cell 2, we can move downward from 3 and rightward from 1. So we'll be taking in both these values, adding them, and this would give me the total number of ways to reach this particular cell containing the value 2, and it would be 3 here. Now checking in for this value 1, the downward one is the upward, the upward value is 1, so we cannot reach here, so the value would be 0. Now for this one, the upward value is 2 and the rightward value is 1. So there are both the ways we can reach this particular one. So we'll be adding these two values, 0 plus 0, which gives us 0. Now coming into this particular cell, we have the upward value to be 3 and the right value to be, the left cell value to be 1, meaning we can traverse both upward, downward and rightward direction. So we'll be adding them, 1 plus 0, which is 1. Now for the next cell 3, we have 1 above and 1 towards the right, but we cannot move from 1 to the downward direction, but we can move from here to the rightward direction, meaning we'll take in this value and place it here. Now coming to the last cell, we'll consult the rightward and the upward cell, the leftward and the upward cell. The left cell contains 3 and the upper cell contains 2, meaning I can traverse downwards and I can traverse rightwards also. So we'll be adding both these cell values and we'll get the answer. So the final cell value will give us the answer of reaching this particular cell, which is nothing but 4. And in order to calculate the maximum path, we'll be performing the same operation and we'll be keeping a note of the cell values that we are considering, and we'll be adding them, and like whilst adding, we'll also check if the value becomes maximum or not for that particular cell. So let's jump right onto the code. Now to begin with, first of all, I'll store the size of the matrix, that is nothing but equal to matrix dot size, since it is a square matrix. And also they have asked us to take the mod of the result, since the value could be very large, and for that I'll be using another variable mod, storing in the mod value. And let's create a vector to return the answer, and the size would be 2. And also we'll be creating the DP matrix, but we have to send in the sum as well, right? So along each cell, we have to calculate the maximum sum. For that, we'll be using a vector, well, not a vector, a 2D array of pairs. And using those pairs, we'll be able to make a note of the computed path and also the sum along that computed path. So for that, I'll be creating a vector of, a 2D array of pairs. Now let's loop over the array. First of all, we would have to initialize all the values of that cell with 0. So let's do that. And I equal to 0, I less than n, I plus plus, for int j equal to 0, j less than n, j plus plus, and we'll store in the dp of ij value to have 0th value and the matrix value itself to calculate the sum as we go. And we have to like initialize the first, that is the top left value, to have the value 1. So it would be dp of 0 comma 0 equal to 1, well dot first equal to 1. Now after doing this, we'll be moving on with the computation of the path and the sum along the path. So we'll again loop over this I less than n, I plus plus for int j equal to 0, j less than n. Now we have to like make a note of the make a note of the values which are reaching from the top and also from the right direction. So for that we'll create variables. Let's call them up path or up path. Let's initialize them with 0. Let's take another variable left path, initialize it with 0. Up sum, which is nothing but the sum coming up from the upward direction, let it be initialized to 0. And another variable left sum, which is the sum coming in from the left direction. So after doing this, we'll make a check for each of the cell. So we have to first check if the I value is greater than 0 or not for these cells and for these cells. Well, for these cell we'll be checking if I is greater than 0, and for this first column we'll be checking if j is greater than 0 or not, and we'll handle them accordingly. So if I is greater than 0, and we'll be checking if the matrix value for the cell to the right, for the cell which is above it, which is nothing but I minus 1 and j, if it is equal to 2, meaning we are only allowed to travel from the upward direction if we have the variable 2. And we'll be checking if we have the variable 2 or the variable or the value 3. So we'll be checking again for the same upward cell, and if it contains 2 or 3, and if its dp value is well not 0, then in that case we'll be computing the path value. So this is a simple check we are doing just to improve just to optimize the code. So dp of I minus 1j, if the first value is not like 0, then in that case we can calculate the up path to be equal to dp of I minus 1 j dot first, and we'll be calculating the sum to be up sum equal to dp of I minus 1 j dot second. Now after this is done, we can do the same process to calculate the value coming in from the right direction, and for that we have to make a check if our j is greater than 0 and our I would be as it is, and we'll be moving one step to the left. We'll be checking if the value is 1 or 3, because those are the only two values through which we can move in the right direction. And we'll also be checking if those values are 1 or not, I mean 0 or not. If they are 0, then we need not calculate for that particular cell value. And similarly we'll calculate the left path and the left sum, that is the sum coming in from the left direction and the path from the left direction. So after this is done, we have to store the value, and to store the value we'll be taking the current cell, which is nothing but dp of I comma j, creating a pair. The first value would be maximum of dp of I and j, which is the first value itself, that is the value which is already present, and the next value would be the computed value, which is nothing but the left path value and the up path value, because either of those value could be like our result and we have to add them. For example, in this case the upward value was 2 and the left value was 1. So in that case we added both these values, 2 plus 1. So we have to add them and we have to take in the maximum value. So it would be left path plus up path, and we will be taking a mod on that value. And also for the second value within our pair, we'll be taking the maximum value again, and that value would be nothing but dp of the current value, like the current value itself. Well, right, the current value, and we'll be adding the maximum value between the two paths. That is, the maximum value could be either one, that is coming in from here or from here. So we would be handling that, and it would be maximum value of either left sum or up sum, well, not right sum, up sum, and we would be taking a mod on that value. Now after this is done, I guess I have computed all the required values. Now we simply have to store in a result in our result variable. So our result 0 would contain the number of paths, which is stored at dp of n minus 1, n minus 1, and we'll be taking in the first value, and let's mod it. And also for the sum, we'll be taking in the second value of our last cell, n minus 1, n minus 1 dot second, modding it to a mod. Now this is done. Let's return the result. All right. The left path and up path mod. Brackets are correct. dp of first or the left path mod, dp of ij dot right. I have to take in the second value and not the dp of ij itself. Also, we have to make a check over here, because this value, the calculated value, it could be 0, and that is possible if there is no particular path from like the top left to the bottom right. So we would have to make a check in that case, since we are calculating our like the sum value as we go, the value may get added up and we might get the wrong answer. So for that we'll make a check. So the check would be as, like, we would be checking the last value, and we'll check if the first value of the last cell, if it's 0 or not. And if that is the case, if that is like, if the value is not 0, then we'll simply be returning the second value with the mod, else we'll be returning 0. So I guess we are done and we can now return the result. Another compilation error. All right, I forgot to add in a semicolon here. All right, let's try and submit. So that was it for today's video. If you have any doubts, you can ask them in the comment section, and thank you for watching.